Yes. So see here that at the top we have four routers, right? At the top we have four routers. Then in the middle, this one is your terminal server. So what? Terminal server. So what is the back of that? Yes, okay. First four is the router, next is the terminal server, and next four are the switches, and these two are the firewalls, that is the ASA firewall. You don't have to use this two because we are just focusing on the CCNA part. So we have to discuss for the routers and the switches. And this is for the terminal servers where what can happen that all these particular individual devices, all the four routers and even four the switches will be connected to the server.
Vishar, you're not audible. It was
Yeah.
very slow.
So now what can happen that like if you want to access individually all the devices, you need to put putty into the individual devices every time because each devices has console ports. Okay, fine. 1 minute. Let me confirm. Yes, top four are the routers. Then next one we have is a terminal server, and then below four are the switches, and at last the two devices are the ASA firewalls. Okay. Now what happens? I told you that if you need to access the devices individually, each devices has a console port. Okay. So you have to put console port on each devices to configure. Let's say, for example, I'm configuring the first router. So I need to put this console port into the first router. Then I will configure the first router. Then it is done. Then you want to configure second router. You have to remove the console port from the first router, put it to the second router. This is one option. One more option we have that we have taken a terminal server. What happened? With this terminal server, all this four routers is connected. Same with this terminal servers, all these four switches are connected. Now, no need to individually go into the individual devices and they connect with the console port, right? What can happen? Yeah, directly you can connect to this terminal server with the serial port or even console port and do the configuration. This is the one option. One more option. Let's say you don't have this console port. Now you want to access these all devices. Then what will happen? Your terminal service server will be connected to the internet, right? With the help of telnet, you will access terminal server, and with that you can access all these multiple devices. This is called using RDP. Okay, but now what we will do? We will individually connect to the individual ports, individual serial console ports of the devices, and we'll do the configurations. Okay, fine. Now, see. So the these routers are Cisco 28 double series of the routers. Cisco 28 double series, and these are the switches. This is Cisco Catalyst switches 3550. Okay, fine. Now, so you can see here in that uh, all the devices are interconnected with each other. It is acting like a mesh topology because all the devices are connected like each other. Fine. I will send one more photo. And see in the group that See the images. In that, you will find that at the back we have one power port, like from where the power is being supplied. And see, if you are seeing there, one console port is there with that blue color cable has been connected. See that images in the WhatsApp I've shared. Okay, so it is going to have one console port and auxiliary port. So console port, I have discussed that it is like a configuration port, and auxiliary port is what? Backup of the console. What it is? Backup. If console port is not working, then you will try to access using what? Auxiliary ports. And rest two are the USB ports. Fine. Now we'll start the configuration. See now. So first you will connect this, then come to device manager. See, are you seeing here? We have a COM port. What is it in? COM 10. So now you open putty, then come to the serial. Okay. Then change here from 1 to 10. Fine. Now you come to this one, serial. Then flow control, you have to put it as a none. The reason because when you will try to access it, it will show you multiple different means flow. We want to see the only normal flow. That's why we had done this. Now you open this. You are able to see one of the right? Yeah, yeah. Okay, so this is router 4. So now you want to check, let's say, what all the interface we have here. So come to enable, yeah. Give show IP interface brief. So we have two interfaces here. One is G0/0 and one is where IP has been configured. And on more that is 0/1, we have not configured any IP, right? So come to config space T. Okay. Now let's say we want to configure any IP on the interface number G0/1. Fine. So interface G0/1, IP address is let's say 192.168.1.1.255.255.255.0 and no shut and give exit. Okay. Now how will you verify? Do show IP interface. So we have configured one IP on this particular interface as well. That is called as a G0/1. Okay. Now, if I will try to connect to different devices, I need to change the port, console port. No.
Hi Vishal.
Yes.
Here, the G0/1 like gigabyte Ethernet port, it's like
Hmm.
protocol is mentioned as a down, like why it is.
Like we have not set any protocol, that's why. See, the status is up, but we have not configured any of the protocols over there, that's why. Okay.
Yeah, okay.
Emails. Yes. So like this, we are accessing here. Switch one also, correct? So enable configs. Okay, you can give check it. So interface brief. Show IP interface brief. Yeah. So these are the port numbers that is present on the switches. Correct? All these port numbers. And it is visible also, right? Yes. You can see there also. All these port numbers are there, including even fast Ethernet and even gigabit Ethernet ports. Correct? No? So if device is getting started, it will take time to boot. Okay. Let it start first. It means on the router 4, on one of the interface G0/1, we have given the IPS 192.168.1.1. Same as what we will do on the router 3, on one of the interface, we'll give the IPS 1.2 and we'll try to ping. Correct? Okay, we are on router 3. Enable. Now show IP interface brief. Okay, so see what happened now. Here, one of the port is having already one IP and it is being saved also. That's why it is showing you. Already it is there. Okay, and here we have all the port. Let me verify. So IP route, okay, now route, then show run in the section of route. Okay, this is a different IP source route. Fine. Now, okay, so come to config space T and give one IP here. Let's say on the interface G0/1 will configure the IP. Yeah, this one. Okay. So interface G0/1 IP address is going to be 192.168.1.2, 255.255.255.0, and give here no shut and give here exit. Okay. Now do show IP interface brief. So yes, we have configured the IP on this, correct? Now we try to ping, do ping to 192.168.1.1. Okay, it's pinging, right? Pinging it is because it is directly connected. How? You have made it directly connected because you have configured both the interfaces with the same network. See, there we have configured as 1.1. It means, let me show you the topology. So like this, here we have router. Okay, it has one port. Let's say this is G0/1. Same as we have a router. Here we have G0/1. So if these ports are directly connected, here you have configured the IP as 192.168.1.1. This is, let's say, router 4. And this is router 3. You have configured here the IP as 192.168.1.2. It means they are having a common network. If they have the common network, it means without routing also, they will ping. Correct? No? Whereas if you will verify on one of the interface, we have a network as 10.1.1.3. It means that here what is there? We have a different network. If you want to reach this particular interface, what is required here? Routing is required. Okay. So if now the router 4 and router 3 is connected now. So if you want to reach to other side of the network, then we can reach. But the thing is here, already we have configured one more IP, right? Okay. It means it is also directly connected. Correct. So if you try to ping, what was the IP there? 104 on the router 4. To show IP interface brief. Let me check in the other devices as well. Yeah, IMP router 2, enable, show IP interface brief. Okay, here we have this is 10.1.1.2 here, correct? We are on the router seconds. Then show IP route. Okay, yes, see. It means what is being done here? Protocol is running. IP routing has been, it is running. That S star means what? Default routing is done. Via what? 10.1.1. It means using next hop it is done. How will you verify? Show run in the section of route. So see, the command has been given. Right? No? Yes. IP route, then this network address, and this is any submit mask with a next hop IP address. That's why it is given here. Correct? It means it is trying to reach where? On the router 1. Correct? No? That's why it is having the IP as a 10.1.1.1. Correct? No? If you try to ping 10.1.1.1. Yes, it's pinging, right? Correct. Now, even you can verify what all the IP has been configured on the router 1. On the router 2, what is configured? You can again verify show IP interface brief. It's already there, right? Correct. Now, even we can remove this routing. No problem. Now, we will do it on the first router. See, until and unless you have not practiced on the Cisco packet tracer, then it will be very difficult to understand the disk topologies. The reason, because see, what happens when you connect using the Cisco packet tracer, it is very simple, correct? And here everything is connected with a switch, and here also it is like a mesh topologies. Yeah. So you need to always imagine that okay, this is my interface connected to this interface like that. And in the Cisco packet tracer, it is clearly visible also. Okay, this is my interfaces. So if I will try to ping it from here to here, I require routing here, everything, correct? No? But in this particular real scenario, you require little imagination as well. Show IP interface brief. Configure the IP, correct? No? Now here
Vishal,
also we can, yes.
the third interface it should be a VLAN. What it's saying SSL?
No, like this is already, it has been connected to one firewall also. And we have a Cisco firewall, ASA firewall. And in that it has been configured as a name has been given as a SSL VPN file interface.
Okay, but this
Right.
is VLAN only, right? With
Ah,
the port is VLAN port only.
yes. So it is not required for us. And even this is a router, no? That's why it is showing you all these things. Generally, where we find a switch VLAN information on the switches.
Yeah, but
Okay.
in when I open my packet tracer, in that it's showing VLAN only for
It's a,
the
source.
router also.
Correct, correct. Source. So this is not required for us. This is completely dedicated for the security part. Now on the router one, we will configure one more IP interface G0/1 as IP address, let's say 192.168.1.4 and 255.255.255.0 and give here no shut and give here exit. Understanding what is happening here? Okay, let me first verify and I will show you what will. So are you understanding? Every time we have to change the ports. If you have been connected to the terminal server, no need to do this, right? Then how will you access? I am using console port. So console port is connected to terminal server. Okay. It means telnet is not required. Why? Because we have a serial connectivity. Now, if you want to access router one, how will you access? For that, there is one command, control, alt, 6, and X. I will write the command, don't worry. Using that command, what will happen? You will come to another router. If you will click over that command, it will come to server terminal. It will ask you on what router you want to go. So you will write router one, give enter. So you will come to router one. Same as again, you will give the same command. It will come to server terminal mode. Again, it will ask you which router you want to go. Router two. Done. Now you want to access switch. Again, you will give server and this control alt 6 and X. It will come to server terminal mode. Again, you will give code. Now I want to access switch one. So you will type here switch one, everything like this. This is for RDP access. Okay. RDP, remote desktop.
So what if host name channel was not configured?
You can configure anything. No, generally it is there. It has been configured like that, no, so that we can understand it. Okay, so we're on the router one, router two, and verify so IP interface brief. Yeah, so to ping 192.168.1 dot. Sorry, ping. What is the IP we have configured on the router one? 1.1 or 1.4? Yeah, 1.4. Yeah, see it is pinging. How it is pinging? Now see what is the my topology? According to this my topology is here we have a router one. Then we have, let's say, router two. Correct. Then this side, we have 10.1.1.1. This side, we have 10.1.1.2. Now only I have configured on this interface as 192. 168.1.4, and here already it was configured as 192.168.1.1, right? Now on the router 2, one command has been given that you want to reach IP route to any network. It means 0.0.0.0 with any subnet mask 0.0.0.0. And next, what is given here? Next hop IP address, right? So it means you're telling here that you want to reach any network, correct? Via what? This next hop. So whatever the network information coming this side will be reachable for you. I have not defined that you want to reach this 192.168.1.0 only. We have not given this command, no. We have given to reach any network, and that too also when you're trying to ping it from here to this network, it is able to ping. Understanding how it is? Because of default routing. Correct? Fine. So same topology is present on the lab in the lab also. Like this only, what you will do? You will connect to the individual devices. There you will not be able to connect like this with the console ports. Already it is there in the server terminal. You have to use that command that I told you, that the command is control plus alt plus 6. This you will click at the same time, control alt 6. After leaving this, all these three keys, you will press X. This is a global command to change the devices when you are using server terminal. Command to change the devices with the help of server terminal. And when you have to access real devices, what is required here? You need to install putty. Putty software you have to install. You can just, it is very simple. Go to that Windows store, Microsoft store. In that you will type putty. It is there, install it. Okay, other also options we have, mobile system, everything, but you can go with the putty as of now. Fine. We can use this mobile system and around all these things. When will you come to CCNP part? It means like I think in the last class I have done configuration using that EVNG. So in that I was using mobile XTOM. Okay. Benefit, it is little more colorful. It is simple. And one more benefits, like what will happen now? As of now, what we are doing, just we are changing the devices and it is showing you, okay, this is router 1, this is router 2, router 3, like that. When you will use mobile XTOM, it will always show you all the connected devices. Let's say this is router 1, this is router 2, this is router 3, this is router 4, like this. You just click, you will come to router 1, click, come to router 2, click, come to router 3. So more advantage we can get it from here compared to what we have in. Huh? Huh. Okay, but as of now, you can install this one. So if you need to practice today for the real devices, you have to install this putty. Understood? Now, why whenever my device is off, like I have on it now only. So though I have on it now, so this IP has been configured and it is present. Why it is present? Because after giving this IP, after giving the routing commands, at last what is giving, what has been given? A write up command. Write up command means what? To save. Okay. WR if you will give, then whatever the configuration you have done, all the running configuration stored in the RAM will be stored where? In the NVRAM. Correct? That's why it is stored. So there. Understanding my point? Clear? So we'll start with the dynamic routing first now. Let me stop the device. Okay, so in the last class, we have done with the static routing and default routing, correct? No? And today we have to start with what? Dynamic routing. So first thing, what do you know about dynamic routing? So dynamic routing, it is a process that involves multiple protocols, multiple different protocols to identify the best path automatically. Okay, here manual intervention is not required here. Hmm. So it says here that dynamic routing refers to the use of algorithm and protocols to automatically update and adjust the routing table in response to the network changes without requiring any manual interventions. So router in this, what it does, it automatically shares and update the routing information with each other, right? So it refers to what? It refers to the use of algorithm and protocols. It means if you're using any protocols, that particular protocol will use certain algorithm to identify the best path. So different protocols is going to use different algorithms. Okay. So automatically update and adjust the routing table in response to the network changes. It means whenever there is any change in the network, then it is not required to change the path. What will happen? Automatically with the for these dynamic routing protocols, the router will change its path automatically. So in the case of static routing, what happened that their destination address was required. It means network admin should aware about the destination address, means where I have to send the packets. Whereas in this case, dynamic routing, that is not required. It means, let's say, for example, we have a router. One, this side we have a router. Two, this is a symbol of router. Okay. Now they both are connected. This side we have a network 2.2.2. Fine. On this interface, we have 192.168.1.1. On this interface, we have 192.168.1.2. And you want to reach from router 1 to this network. So when you are using static routing, what command you give? IP route to reach this network, then submit mask, then you write next hop or exit interface number. Correct? But when you are using here this one, dynamic routing, any protocol in dynamic routing, what you write? You write here router, then you will write here protocol, name of that protocol. For example, if I'm writing OS, I'm using OSPF, what I will write? Router OSPF. If I am using EIGRP, what I will write? Router EIGRP. If I am using routing information protocol, what I will write? Router RIP or BGP, router BGP, like that. And then below, you will write here network. Which network? Not the destination network. No, the network connected with the routers. So if on the router one, we have one connected network that is 1.0. So you will write 192.168.1.0. Why it is 1.0? Because you have taken it here /24. That's why the network part will be 1.0. Whereas on the router 2, the command you will give here is router, then you will give again one protocol, then you will give again network information. And when you are giving, we have to remember one part here that you need to give one common network information also. Let's say, for example, if you have not given this, if you have just given 2.2.2.0, then with the help of this, they will not be able to communicate. Means if you will try to reach from router 1 to this network, not possible to reach because they should have the information regarding what? One common network. So you have to give information one more network 192.168.1.0. And these two are what? Common network between the router 1 and router 2. Correct, no? So here what you have done here, on the router 2 also you have advertised what? Connected information. This side also and this side also. Fine, no? So this network is connected with router 2. You have advertised this network means this network 192.168.1.0. Don't get confused with the IP or the network. Okay. So we are advertising here what? Network, not the IP. So this network is connected with the router 2. So you're writing here this one also. And same as this one, this side, this network is common for this router 1 also. That's why you're writing here. Clear? So what we write? Connected network. That's why it is told that in dynamic routing, information regarding destination address is not required. Okay, if you have shared all this information, then what will happen? This router will start sending hello packet messages to verify whether it is reachable or not. If it is reachable, then it will find the best path using the protocols and will have the communications between them. Right? So that's why it is written here. Dynamic routing uses what? Algorithm and protocols to automatically update and adjust the routing tables. Correct? Now, this dynamic routing has been further divided into subcategories. So first, we will write here dynamic routing. It has been categorized into two different parts. One is called as a IGP. Now, what is this IGP? It is Interior Gateway Protocol. And this side we have is EGP. That is called as a Exterior Gateway Protocol. IGP and EGP. Now, question can be that on what conditions this categorization has been done, IGP and EGP. So this IGP and EGP division, or we can say categorization, has been done with the help of AS number. We'll come to every fault. Okay. AS number is called as a autonomous system number. Okay. What is AS number? Autonomous system number. Now it is what? It is a grouping of devices that is being configured and managed by single organization. What it is, AS number? It is a grouping of devices that is being configured and managed by a single organization. Let's say, for example, you have 10 routers. If all these 10 routers is being managed, being configured, and being controlled by an organization, let's say Airtel. Okay, so this is one IGP or one AS number. Okay, same as we have 20 routers that is being managed and configured by Reliance Jio. It is a different AS number. Okay, if you have to enable the communications between the devices located in the same AS number, IGP. If you have to enable the communications between the devices located in different AS number, EGP is required. Okay. So in example here, you can say examples can be ISP, Internet Service Provider, but not only ISP. It can be any other organization as well. Okay. So this is one example. And other organization you can write. Correct. Who gives this ASN? It is given by IANA. IANA. How does it gives IP version 4? Same as. Okay. So we can write here that communication between the devices located in same as is done using IGP. And in this, what we will write? Communication between the devices located in different is done using EGP. Okay, so based on this AS number only, this categorization has been done. Now in the IGP and in the EGP, we have certain protocols. You will not use only IGP. IGP means what? Under that, certain protocols will be there that you will be using. Same as in the EGP, we will be having certain protocols that we will be using, right? So in this IGP, what protocols you have? Or you can say, base first we will divide what all the metric we have. And based on the different metric, what all the protocols are coming here, right? So first we have distance vector. What it is? Distance vector means here, distance vector will be the metric to identify the best path between the source and the destination. In that, we have two protocols. One is called as a routing information protocol. In short, we write it as a RIP. So it is routing information protocol. Okay, one more we have that is called as a IGP or IGRP, not IGP. It is interior gateway routing protocol. It means that there will be two protocols that is going to identify the best path based on the distance metric cost, distance metric, distance vector metric. Correct? After this, we have one metric that is called as a link cost. Okay. So which one is going to use link cost as a metric to identify the best path? It is OSP. Open shortest path first. And one more we have that is called as a IS. IS, that is intermediate system. Intermediate system. Okay. Then next, after this, we have one more metric cost. Next, we have is a hybrid. Hybrid means what? It is the combination of both distance vector plus link state. So we have one protocol that is going to use this hybrid is called as what? EAGR. Enhanced interior gateway routing protocol. It means that if you're using IGP, means if you have to enable the communications between the devices located in the same AS numbers, so we have multiple protocols for that, right? RIP we have, IGRP we have, OSPF we have, ISIS we have, AGRP we have, right? So among this all protocols, which one is the most commonly used protocol?
OSPF.
OSPF. OSPF is the most commonly used, right? We'll come to that part. We'll start with the RIP only, and I will tell you what is the demerit with the RIP. Why don't we prefer that? Same as for the IGRP also. Then for the AIGRP also, then for the OSPF also. Okay, and in the EGP, we have only one protocol. And in this, it is going to use what? What metric? Path vector. Path vector. And in this, what is the protocol we have? Only one protocol that is called as a BGP. Border Gateway Protocol. Correct? It means that if you have to enable the communications between the devices located in different ASM, what will you use? BGP. Clear till here?
Vishal,
Hmm.
we have IBGP and EBGP also, right?
Right,
Bounded
right.
path.
We have that IVGP and EBGP. But generally, you will come to that part when you will start with the BGP. So there it is not that it is like IBGP. IBGP is also a part of this EGP only, and where we will be having the communications between the devices located in the same AS numbers.
Okay.
Okay. But generally, what we prefer? EBGP.
Okay.
EBGP, right? So well, that is there, but it is not in the CCNA part. So we have to discuss in the routing, CCNP routing. Even we have in the EIGRP also internal EIGRP and the external EIGRP. But I'm not telling that if we have external EIGRP, then it is EGP. No, it is IGP only. But when will you have this external EIGRP? Do you know? When you are having the communications between two protocols, let's say in the same AS number, you have 10 routers. AS number is same, 100. For example, you have 10 routers. And what you did, that with 5 routers you have done OSPF. With 5 router you have done EIGRP. Understanding what happened? Let's consider that this is your one single AS number. You have a single AS number. In this, we have multiple routers like this. Now, what you did that with this 3 routers, first 3 routers you have done here OSPF. Okay, between all these 3 routers. Then between these 3 routers you have done EIGRP, right? But this all router is a part of single AS number only. That is, let's say 100. And this is being configured by one organization, that is Airtel. So if they are having a common AS number, then it is IGP, right? But though it is a IGP, but what you did, you have used here 2 different protocols for the communication purpose. But between them, you have to enable the communication. Okay. So here, what is required? Redistribution is required. What is redistribution? As of now, not required. It is completely CCNP concept. Okay. When you are doing this redistribution, and when you check in the EIGRP, it will show you external EIGRP, not internal EIGRP. Understanding? Correct here? So this is why we get one information as a external EIGRP. Though it is a part of IGP only, but as we have used different protocols here, and we need to enable the communications between them, in that case, we will be having external EIGRP. Even one more thing can be there. Let's say this is a part of IGP only, 100, but you have done subcategorization. Subdivided this particular big AS number into the small AS numbers. In that, you are using different protocols. Let's say you having 100 AS number, that is a broader concept. Under that, you have created 2 different AS numbers, let's say 10 and 20. Though it is a part of 100 only, but finally what you did, you have divided it further into different AS numbers. And in that case, you are using AS number EIGRP for AS10, EIGRP for AS20. Again, you need to have the communications between them. Then what is required? External EIGRP, right? So technically, it is a part of the same IGP, but because of using different protocols or because of having subcategorization of the AS numbers, we can have the concept of the external EIGRP. Understood this? Now, here, do you mean by the term distance? First is what? Distance, right? Distance means how far the network is located. Okay. Distance is what? How far the network is located. Whereas vector is what? In which direction it is located. Correct? In physics, we would have discussed a scalar quantity and vector quantity. A scalar quantity is directionless, whereas vector quantity is direction. Speed is what? Speed is a scalar quantity. Velocity is what? Vector quantity, right? Speed don't have any direction, whereas velocity has direction. So as it is going to have a direction, that's why it is called as a vector. So like why it is required? Because let's say you are going to have This is router 1. This is router 2. Then this is router 3. And this is router 4. And this is we have a server. Now you want to reach this server from router 1. You have two options. You can go via router 2 and router 3 and then reach the server. You can go from router 1, then router 4, then reach the server. Okay. Now distance is what? How far the network is located. Correct? This is my server network. So how far it is? If you will go by this one, you need to cross two routers. If you will go by this one, you need to cross here one router. It means based on what you are identifying the best path, number of hop counts. Number of hop counts between the source and destination. Okay. Distance is what? How far? How far is how we're going to calculate based on the number of hop counts that is we are going to cross to reach this particular server. Fine. Now you know that okay, this router, this server is located in my this direction only. So you will send the traffic via this direction only, right? No, because see, it may be possible that you have multiple different directions also. So how you identifying that I have to send it to this direction only because your network is located only in this direction. That's why distance also you are identifying and vector also you are identifying. Correct? So now you identify that this is my best path, that is fine also. Number of hop counts you have used as a metric to identify the best path. Now what happened? Let's say this is having, here the connectivity is gigabit Ethernet that provides you a 1000 Mbps speed. Same as here also and same here also. And this side what you did, you have used Ethernet cables. That is the speed is 10 Mbps, 10 Mbps. Now tell me which one is the best path. 1000. It means that number of hop count is not enough to identify the best path between the source and destination. Apart from that, what matters? Speed. Okay. So when you are discussing about distance vector protocols, it is going to use only one factor that is called as a distance vector, that is called as a number of hop counts. So now if I am using routing information protocol, and in the routing information protocol, you have used this scenario. In this also, your router will send traffic via this one. Why? It does not consider speed as a metric. What it considers? Hop counts only one factor. And this is the biggest limitation of the routing information protocol. Okay. It depends only on the one factor that is called as a number of hop counts. Even I was having one alternate option with higher speed. It was not selecting that particular route because it does not understand that part. What it understands? Only one thing, hop counts. Hop, H-O-P. What is hop count? Number of router.
Then where we use our
Huh? We don't use now.
why study
Routing information protocol is a very old protocol
like is
that is not preferred now. As the name only suggests, it is in a rest in peace. Okay, but I cannot say that completely it cannot be used. It can be used, but it is having very limitations. Okay, clear with this? One more factor of this RIP. First thing, you can write that a routing information protocol, it uses only one factor to calculate the best path, that is number of hop count between source and destination. Right? Then yes, so what we were discussing that about RIP, no? So what we have written here that it uses only one factor to calculate the best path, that is number of hop counts between source and destinations. Now this RIP has been categorized into three different types. One is RIP version 1. Then we have RIP version 2. And one more we have that is called as a RIP NG. This is for next generations. And the last one is for IP version 6. Rest two are for the IP version 4. Now, what are the differences between RIP version 1 and 2? See, RIP version 1, it supports classful network. It support classful network, first thing. Second thing, that it sends update using broadcast message. Means it sends update using what? Broadcast. Means sending the messages to all the interfaces connected with that routers. Then one more thing, it does not support any authentication. Okay, it does not support authentication, right? Next thing, maximum hop count. It has maximum hop count. Maximum hop count is 15. It means maximum 15 routers only it can cross. Beyond that, not reachable. Because it is having certain limitations. Okay, it has measurement of capacity only. This protocol was designed like that only. Okay, same. We have like a RIP version 2 also. RIP version 2. But it has certain advantages and again certain disadvantages, same. So it supports classless network. Means here we have written that it is for classful, but it is classless. Then it sends update using multicast address. Okay, it sends using broadcast address. It sends using multicast address. And what is the multicast address it uses? 224.0.0.9. It supports authentication, but again, one more limitation. Maximum hop count is 15.
Is it like only supports classless network or both classless?
Both. When I'm telling classless, it means both it can, no? Correct? What do you mean by classful and classless? When we are using default subnet mask, it is classful. And when we are using any other subnet mask, then we have classless. Correct?
Vishal, so
Hmm.
RIP version 1 that having broadcast, it sends update every 30 seconds.
Correct,
Version 1 or version 2?
Both. Both sends every 30 seconds, okay?
Oh, for both.
See, they both sends updates every 30 seconds. Sends update every 30 seconds. Means even if there is no any change in the network, that too also, this router is sending the updates every 30 seconds. Okay, imagine what will happen. If your friend is sending you messages every 30 seconds, what will happen to you? Correct? No, same thing it is doing. No, what this it is doing, routers, there is no any change. But again, it is sending every information every 30 seconds. Okay. So again, just what. So we discussed here that we have RIP version 1 and RIP version 2. Okay, all the differences we discussed. Then limitation is that if we compare with any of the RIP versions, so limitation is that it sends updates every 30 seconds. One common means you can say similarities between the RIP versions. And apart from that, it has maximum hop count limitation is also 15 only. This is the biggest limitations. Okay, and RIP NG, that is for next generation, is for what? IB version 6. Okay. So we will take here two routers. Then between router 1 and router 2, let's consider this is router 1, R1, and this is as R2. So here we have IP as 192.168.1.1/24. And this side we will take as 192.168.1.2/24. Okay. This side we will take here, let's say two networks we'll take. One is 2.2.2.0 network, or this is the IP network will be obviously 2.0. And next is 10.2.2.2. Okay, this two IP. Now come to the router 1 first. CLI give no, enable config space T, host name as router 1. Now interface is G0/0, IP address is 192.168.1.1.255.255.255.0. Give here no shut and give exit. Same as come to this router second. CLI give no, enable config space T, host name is router 2, interface is what? G0/0, IP address is 192.168.1.2.255.255.255.0. Give no shut, give exit. Then interface loopback 1. IP address is 2.2.2.255.255.255.0. Correct? No?
Yes.
Then give exit. And interface loopback 2. IP address is what? 10.2.2.2.2.255.255.255.0. Give exit. Now, if you to verify, you will give the command do show IP interface brief. Okay, so we have configured the IP. See, correct now. But if you'll try to ping from router 1 to this network, what will happen? It is not going to reach there. The reason? Because it is a different network. So here now we will use routing information protocol. Okay. So for the first router, you will give the command router, then give a question mark, and it will show you all the protocols names like BGP we have, EIGRP we have, OSPF we have, RIP we have. So what we will write here? RI. Okay. By default, you can change the versions also, but when you will not define the version, it will use version 1. Okay. When you will write here version and when you will give the question mark, it is showing you here what? Version 1 and version 2. I may specify also that I want to use here version 1 or version 2. Or if I will not specify what it will use, version 1. So we'll specify here as version 1. Then network is what? 192.168.1.0. 1.1 is the IP address. Okay. 1.0 is the network address of this particular IP. When you will give a question mark, it is not telling you to write anything. Okay. So we'll write only one part, that is network address. That's all. Done. Give exit. Same thing you have to do it on the router 2 as well. Now, what will you give? Router, RIP, version what we are using here, 1, network, one common network again, 1.0. So 192.168.1. Then one more network, that is what? 2.2.2.0. Why it is? Because we are using flash 24, that's why. Then one more network, 10.2.2.0. Done. Give exit. Now first we will try to ping. Now come to router first. Give here command do ping 2.2.2.2. It is pinging. It means routing has been done. Now you check on the router 1 only, same thing. Routing table. How will you check? Do show IP route. Now you see the differences. When we are checking the routing table, it says here R. R is for what? Same routing information protocol. But when you are checking here network, have you given this network? No. What you have given? 2.2.2.0. But what it is showing you? 2.0.0.0. Why? Because 2.2.2.0/24 is classless. This IP belong to means 2 is a part of which class? A. And default mass of class A is what? 8. That's why it is maintaining here classful. Though you have advertised classless network, but what it is maintaining? Classful. Why? What we are using? RIP version 1. And RIP version 1 uses what? Classful. Same as for this one also. We have advertised here 10.2.0, but what it is writing here? 10.0.0.0. This is the limitation of the RIP version 1. Okay. What is this 120? 120 is the AD value of the routing information protocol. It means RIP has a AD value of 120, 120. And what is 1? Number of hop counts. It means to reach this particular network, I have crossed only one router. That is correct also. Correct, no? So note down the commands that we have written here. Because you have to try this today on the real devices. Okay. Same thing you will do. So they have a common network. So on the real devices, you may assign only one IP, that is 2.2.2. Fine. Not required to give one more, that is 10. So now this is router 1. So what command you will give? Router RIP. Okay. Then version 1 or 2. You will write here version. Then network. What is the network? 192.168.1.0 in this example. Then on the router second, what command you will give? Router RIP. Then version. Then network 192.168.1.0. One more network, that is 2.2.2.0. Correct, no? So we will write here that this is going to be common network between router 1 and 2.
what is it consuming different network, the version of both sides?
It will work, no problem. But the thing is that if you're using one and two both, then when will you advertise the network information? It will, one side it is classful, one it is classless. So it will cause a problem for that. That's why it is recommended to use same versions. Done? Written?
Vishal?
Hmm.
So RIP NG also outdated or still in the market?
See, I'm not telling that RIP is only audited, but we don't prefer this. We don't prefer. Okay. We have alternate options. We have good options. OSPF, PIGRP. That's why we don't depend upon this.
No, because RIP NG I have heard right now only because before I have not
Like
heard.
RIP
Sorry,
NG.
IPv6 you said.
Correct. This is for IP version 6. So as we can see that RIP is only not preferred. So we can say in the case of NG also, instead of using that, we can use OSPF also. So if OSPF also supports what IP version 6, right? You will
Yeah,
come to
yeah, that.
about that when you will start the advanced routing. There you will do the configuration using IP version 6 in the OSPF. In CCNA level, we will be doing static routing and default routing using IP version 6. Okay.
Yeah, a little because when it came RIP NG IP version 6, so I got a little confused because 6 is recently like now it has been used, so that's
See,
why I'm
not
little.
recently. Around, I told you that development work for the RIP version, IP version 6 was started in 2000 only.
No,
And
but
this
the
is
now companies are implementing,
correct.
they're migrating from IPv4 to 6. Many big companies I have heard
Right.
about it, so just I was like, yeah.
Right.
They're vigorously because doing it IP
Hmm.
version 6 now.
Correct. But it is not that this IP version 4 will be removed only. It is also now being used, and you will always find whenever you are having any private IP version, it is going to be version 4 only. Correct? No?
Yeah.
Now, if you want to remove this, what command you will give? See, if you want to remove this routing, whatever the command you have given, just you give no router rip, that's all. Same. Give it here also. What command will you give? No router rip. After giving this, if you will check, it is removed now. If you will check, do show IP route, it is not there. It means routing has been removed. This time, what will you do? Router rip version 2 network 192.168.1.0. Then come to router second, router rip version 2, and network is 192.168.1.0. Network is 2.2.2.0. Network is 10.2.2.0. Give exit. Come to router first. Do show IP route. Okay, let me do it one more time. Router rip. Then you first give no auto summary. Give exit. See what happens now. Some of the routers are the old routers that do automatic summarizations. So for that, you have to give a command, no auto summary. Means you are telling that you need to summarize it to the classful network. You have to use what classless network. So this command is required, no auto summary. But this is only required when you are using old routers. Now, if you are using 15.x series of the routers or beyond that, this command is not required in that. That's why when we will use EVNG in the CCNP routing, will not give this command. And now see, just we have given that command and now it is showing you, right? Where it is, yes. Correct now? It means not only the protocol, sometime it may happen because of the routers also. So this time, though we have used the protocol version 2, but it was showing you only the classful, the reason of the routers. So on the router, you have to give a command, no auto summary. It means what it does, by default, it summarize. Summarize means what? Summarize to the classful network, though you have advertised the classless network. That is the problem. Clear? This is regarding routing information protocol. So this is distance vector is the protocol, is a method by you used by routers to find the best path for data to travel across a network. Each router skips a table and that shows the shortest path to every other router based on the number of hops or steps needed to reach them. Okay, so routers share this information with their neighbors, allowing them to update their tables and to find most efficient route. It means what we are doing here, we are sharing the connected networking information, and based on that only it is maintaining it and forming the neighborship. So one more thing is very important in the case of dynamic routing. Neighborship is very important. Like, okay, if you are seeing here that this router 2 and router 1 does not have any information regarding this network. No, even we have run the protocol, then also we have not advertised this network information with this router 1. We have told this router 2 that you have this network, and using that, this router 2 is helping this router 1 to reach this network. It means neighborship is very important in the case of dynamic routing. If neighborship is not there, then they will not be able to exchange the routing information and they will not be able to reach. Correct? No? Then RIP, it uses what? Hop count as a metric to determine the best path to a destination network. It periodically broadcasts the routing tables to its neighboring routers, and that to every 30 seconds. Supports up to 15 hops. It means 16 is considered to be unreachable and has a limitations in the larger network due to slow convergence and limited metrics. Then commonly used in small to medium size network, and RIP version 1, version 2, this is for classful, does not support VLSM, supports VLSM, includes authentication for more secure routing updates. Clear? In the next class, we'll discuss IGRP. Why don't we prefer IGRP? And just basic configuration of EIGRP. And then tomorrow we'll start with the OSP.
What about the time?
Which one?
Like, hello time.
In RIP, we don't have any hello timers. We have update timers. Okay. We have update timers that is called as a 30 seconds. Whatever the other timers we have, it is not C. RIP is not there in the CCNA. EIGRP is also not there. Just extra we will be discussing here because completely we have to discuss OSPF only, but that too also not in detail. Okay. In CCNA, we will discuss 7 states. In CCNP, we will discuss 8 states. Okay. Whatever the syllabus is there, we'll discuss according to that. Clear, no? Okay, these are the some certain common questions for the interview. Explain OSI model. Explain TCP IP protocol suite. Explain differences between TCP IP and OSI, and why OSI is called as a reference model. Okay, so I have told you question 1 to 5. So what we will do now, we will be discussing questions, what can be asked in the interview, but this is 1, 2, 3, 4, and 5. Write down this 5 question. Tomorrow I will ask in an interview format. And I can ask to anyone. Yes, so write down these 5 questions. Tomorrow I will ask you the question on this 5 question only. Interview questions. Be prepared for that. Then again, next day, I will give you further more 5 questions like that we will be giving and we will be doing. Okay.
Vishal,
Till the end. Yes.
TCP header is important to remember.
Yes, very much important to remember.
बहुत चीजें हैं. So many
And
things
at
to
least that flags.
remember.
Huh. See, in the UDP, we don't have, so TCP header is more important. I'm not telling that you have to remember the sizes of the each fields, not required, but at least meaning you should know. Terms, what is the meaning and what it says, all the
If they
differences.
show the diagram, we can tell without knowing. Like if I see that source port, destination port, I can tell them without
Huh.
seeing. If they ask me, I have to remember each things.
No problem. If you're not able to remember all the fields, then he may ask you the questions. Okay, tell me the differences between them. At least I can say you that you can remember what is source port, destination port, what are the flags we have, checksum we have, data offset we have, window size we have, acknowledgement we have, sequence number. These are the basic terms only. At least we can remember these terms. Clear?
Mhm.
Let me stop recording now.